Now we're going to show the operation of the wireless Tesla coil with a secondary load mirror image to its own, which is a 250,000 hertz resonator. In between there we have a small arc gap, a needle arc gap from one top capacity to the other. Here's our preliminary inputs before we turn the field on. Oh yes, well, back out of here. We also have a scope censoring on this demonstration. That top layer coil is connected to the scope at the highest settings, and we can see the number of bursts per second at the arc gap itself from the arc gap down here. We're going to try to also show the arc gap and secondary arc in synchrony and some neon spatial effects with this process. And then again, unfortunately, our meters have gone out. Turn our amperage meters on again, we'll get going. We always know the process is working when the third meter, 0.12 amps, is registering less than phase 1 is 0.19, and the middle phase, 0.22, is always highest. And paradoxically, it will also have the highest voltage. On our input voltages presently, you should be able to see it's at 0.9 volts, where the other phases are at 0.8. And there's our delivery lines. We like to make record of this to show the difference in ratios that occur in actual operation prior and to after arc gap. What we're going to do here is just go straight to a high arc gap. Those are our preliminary input conditions. We're going to go to a 12.5 volt field, which is, I said, we're going to a 12 volt field. There's our arc gap, and there's our sensor coil. There's our arc gap. We may have problems with the heating of the metal. Here's our scoping. Camera don't seem to adjust to that very well. Now we're going to go back out and look at the secondary action. Giving up about right now. There's our arc gap. I'm going to go back out and show some spatial neon effects. Don't know if that caught, but that'll be it for now. We're looking at our power inputs real quick. Our arc gap seems to be sporadic. Damn thing. I went to a very small discharge. Well, it looks like 4.3 amps, 3.4 amps, 2.8 amps. And up here we got quite a bit, but the arc gap now again looks quick looking. Let's see if we can quickly negotiate a better arc gap. It's working, but it's not. Really learning how to work this damn thing. That's a wider arc out there. I would suppose that quickly drains these. So we want to quickly look at our inputs now. The important thing here to note is we're at 60 volts in the middle. Some 28 volts to the left, phase 1, and 18 volts on phase 3. 6 amps, 4 amps, and 5.5 amps on delivery line. 2.9, 3 amps, 3.5 amps, and 3.5 amps on our phase delivery. And there's our arc gap. And there's our secondary arcing. And we'll close out here with just one more neon slideshow. We'll call that quick.